Alright, here we are making an answer key for the Unit 3 practice quiz. Graph the following points in polar form. Just read super carefully. Polar form, of course, starts over here at 0 and goes counterclockwise. Looks like it's a convenient sort of, I guess you could go 1, 2, 3. The units out here go up to only as high as 3. So 1.5 is right there. If this is 3, and then we're going to rotate past 90 only a little ways. So this is a point, so I make a point. Pay attention to the word vector or point when we do this. So there is A, and I've rotated past 90 to 105 degrees. Okay, you don't have to draw that in, I'm just trying to illustrate it. Then 3 and negative 45 out to 3, and then instead of rotating in the positive direction, we go in the negative direction, and so that's right there. There's B. All right. Add the vectors using our parallelogram method. So I'm going to get my computer out of the way here is what I'm going to do. And then this is just A, this is vector A, and there's vector B. Parallelogram method just means I'm going to sketch a line parallel to this vector I'm adding. So I'm picking this up and dropping it down there, or I'm taking this and dropping it in its same relative position. So I draw a parallelogram where these two arrowheads meet. That is the resultant. Sometimes people make the mistake of connecting this diagonal. It is definitely not. It's the tail of the two of them to the arrowheads for the two of them. Here is the resultant. Okay, and I will abbreviate that. Okay, that's all you're doing, just drawing a sketch, parallelogram method. And then draw the right triangle with a hypotenuse of 7 that has an angle of 15 degrees. Okay, so if I've got a right triangle, I'm going to sketch my best 15-degree angle there. 15 degrees, and the hypotenuse is 7. How long are the other two sides? Well, I'm going to call this, I don't know, short leg is S and L is for the long leg. I only need to solve one of them and then use Pythagoras. So I don't know, I like this. That's the opposite side. This is the hypotenuse. So that's going to say the sine of 15 degrees is equal to S over 7. All right? So then S is going to be equal to 7 times sine of 15. So I hit the sine of 15, and then I multiply that times 7, and I get 1.812. 1.812. Now, while I've got it in the calculator, I'm going to square this, and then I'm going to add that, nope, I'm going to subtract that from 7 squared, which is 49. So I'm just going to subtract that, minus 49. And then I'm going to multiply that by -1 just to get it positive. That's 45. Then I square root it. I can do second square root and then do second and hit the answer button, that minus, and then that will give me the square root 7.6 or 6.76 and 1. All right, so there that is. On a sunny day, a flagpole. There's my flagpole. Is 30 feet tall. There's the sun making a shadow that's 10 feet long, drawn not in very good proportion. At what angle is the sun overhead? Well, we usually measure the angle to the sun this way, as if we're looking up at the sun. So that's the angle that we're trying to make. There's the right angle. This is a inverse tangent because that is the opposite side. Here's the adjacent side. How do I know that? Because I found the hypotenuse is here first. That's the only side that's left over. So tan to the -1 of opposite over adjacent, 30 over 10 is equal to my angle theta. So I get my calculator. Second tangent, 3 divided by 1. Oh, I don't have to do 3 divided by 1. 30 divided by 10, same as 3 divided by 1, just saving keystrokes. 71.57. 71.57 degrees. Okay. On to the last page here. We've got a boat that's being rowed across a lake at 30 meters per minute at a bearing of 124. So this is north. Bearing is all about rotation. Now we're going clockwise from north. There's 90. So 124 is going to be about 34 degrees past. And it's going out with a strength of, if this is 10, 20, 30, there's my vector to represent the direction I'm canoeing in. I'll make that extra thick so you can see it. But a wind is blowing towards a bearing, we'll say in a bearing, the boat in a bearing. I will have corrected that before I post it, in a bearing, or with a bearing of 232. So this is 180. So that's 52 degrees past, and that's at 12. So 12 is a little bit more than my first line, and I'm gone around past 180 to 232. Okay, so I'm going to draw these two vectors. I've done that, and then sketch again using that parallelogram method, parallel to this side, parallel to its opposite side. So the resulting vector is going to be this one. That canoe is really going to go in about this direction here. Okay, and so I would estimate that, well, it looks like it's going at about the same speed, at about 30, and that angle I'm going to say is, I don't know, a little bit past 45, so maybe that is a 30. I'm going to say at 150 at a bearing of 150 degrees. I almost wrote that as an ordered pair, but bearings should not be written that way, just to be clear. So 30, and that's meters per minute at 150 degrees. Okay, but now I'm going to calculate. So to do that, I'm going to take each of these and convert them to polar. So the boat in polar form is originally 30, which is not going to change. But what will change is that 124. Well, 124, that's 34 degrees past my 90. 124 is 34 degrees past 90, so I'm going to go all the way around except for 34. So that is going to be 326. I just did 360 minus 34 degrees because I know that this is like the extra bit. Extra past 90. So that's going to be the same missing bit going all the way around 360. Well, then the wind, that was at 232 if you recall. So now I'm going to go, if that's 232, 180, that's 52 degrees, but I'm going this way around, and I'm going 180 plus the part that with 52 makes 90. So take 52 away from 90, and that finds this bit. So that's going to be what, 38? 38 degrees, and I add that to 180, and that's 218. So that's 12, comma 218. That should be degree symbols. So now I take each of these and I resolve them. So I go 30 cosine of 326, and I get 24.87 when I go into rectangular. So that means it's going to be 24.87 for the x-coordinate, and then I do the same thing but with sine. So I go 30 and then sine of 326, and that's negative 16.77. Negative 16.77. I'm going to do the same thing with the wind. I'm going to do 12 and then cosine of 218, and that's negative 9.46, negative 9.46, and then I'm going to do 12 sine of 218, and negative 7.39, negative 7.39. All right, well then I just add them, and I get my resultant. That's a 6, carry the 1, that's a 1, carry a 1, that's a 7, that's a 4, and that's negative 24.16. They're both negative, so I do that. Here it's negative and positive, so I just subtract. And when I subtract, that's 1, and that's 4, and then that's, 15. So I get 15.41 comma 24.16. So just to sketch what the resultant is I go out 10, 20 there, I go out 15 and down 10, 24. So it's going to be about like that. So that makes sense. That's my resultant. I want to convert this into polar. So I do r is equal to the square root of x squared plus y squared. So I'm just going to take 15 point, and I'm saving time here, squared plus 24, drop off the negative, 0.16 squared, and add that up, and then I square root it, raise it to the half power. That's 28.65. So that's almost 30. My guess was that it was 30. Now the angle is going to be, I just take and drop off the negative, and I do tan to the -1 of 24.16 over 15.41. You should be professionals at this with enough practice. So second tan, and 24.16 divided by 15.4 gives me an angle of 57 degrees, 0.49 degrees. Well, that is this angle right here. So my bearing then is going to be 90 plus that. So when I add 90 to that, I get 147.49 degrees. That's my bearing. Okay, so that's my distance, or my speed, and that's at my bearing. Hope that helped. Good luck.